Okay, so in the last video, we introduced what sigma notation is. We talked about how to use it, how to read the different parts and what have you. And we did one really small example that was kind of woven through the whole entire video. So in this video, what we're going to do is take a look at two more examples where we're focusing just simply on doing the process, actually just evaluating the notation. So learning objective for this video, exactly the same as the last video, because we're just continuing from this notion. So in the last video, we talked about the different parts of sigma notation and what each one of the individual parts tells me. Then we talked about how to use those different parts collectively to find the sum that this sigma notation represents. And so now in this video, we're just going to do another example. And the first example we're going to do is this one. We're going to find the sum of the expression k plus 1 when k starts at 3 and goes to 12. Right? Now, there's only so many things they can do to make these problems challenging or difficult. And one of the things that they definitely can do is to increase the number of terms you have. So in the last problem, in the last video, there were only 3 terms. This one is obviously going to have more than that. So what I would encourage you to do is, based on the last video, pause this right now and give this a try and see what happens. All right, now whether you tried it or not, I'm going to work my way through it. So if you tried it, you can check your work. If you didn't try it, then follow along with me and try and see which part of this are you getting stuck on and figure out how to kind of get the hang of it. All right, so what we said in the last video is the first thing we're going to do is we're going to take this formula and we're going to plug in the bottom number. So in this case, our bottom number is a 3. So in my formula k plus 1, I'm going to replace the k with the number 3. So I'm going to end up with a 3 plus 1. So that's the first thing I'm going to do is a 3 plus 1. And of course, 3 plus 1, that's equal to 4. So that's where I start. Now I'm just going to go to the next integer. So in this case, the next integer is the number 4. And I'm going to plug that in. So the number that comes after 3 is the number 4. And now I'm going to plug 4 into my expression k plus 1. So instead of a k plus 1, now I have a 4 plus 1. And of course, 4 plus 1, that's equal to 5. And I'm going to continue this process. So the next number that comes after 4 is the number 5. So I'm going to plug that into my expression. So I get 5 plus 1. And then that's equal to 6. Okay. Now, I'm going to, for the sake of time, to speed this up a little bit, I'm going to go through each one of my expressions first, and then I'll go through and simplify them second. So after 5 comes a 6. So now I'm going to figure out a 6 plus 1. After 6 comes a 7. So I'm going to plug 7 in, and that's going to give me a 7 plus 1. After 7 comes 8. So I plug 8 in, 8 plus 1. And then comes a 9 plus 1. And then a 10 plus 1. I'm running out of room. And then 11 plus 1. I'm almost done. I'm going to stop when I get to this number here. So 12 plus 1 is my last term. And now I simplify each one of these. So 6 plus 1, that's 7. 7 plus 1 is 8. 9, 10, 11, 12, 13. Excuse me. So there is the terms. That's the sequence that I'm working with. That's the sequence that I'm working with. All right. Now, the sigma tells me I'm finding the sum of that. So each one of these individual expressions, each one of these now I'm going to add to all the others. So I'm going to have this and this and this and this. All of these are going to be added together. So I'm going to get a 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 and plus 13. All right, now at this point, if I was you, there's enough numbers here. I'd probably grab my calculator and type this into my calculator. And that's fine if you want to do that. But I do want to point out something. Obviously, you can just go 4 plus 5 is 9, and then 9 plus 6 is 15, and 15 plus 7 is 22. And you can just work your way right down that way too. And that works. And either way, no matter how you do it, you should end up with the same answer. All right. And so what answer do we get? Well, 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13. 13 was the last number we had. I end up with 85 when I do that. 85. So this whole thing adds up to be 85. Now, not that it matters for this particular video. As far as what you will need to do in the homework associated with this video, this covers it. You're all set. I am going to do a second example that has a more complicated formula, but this is the basic idea for the homework tonight. But in preparation for the next video, I do want to point one thing out to you. Notice if I did a 4 plus 13, 4 plus 13, that's equal to 17. And if I did a 5 plus 12, 5 plus 12, whoa, that also equals 17. And 6 plus 11, that also equals 17. And 7 plus 10, that equals 17. And 8 plus 9, that equals 17. And so altogether, I've got 1, 2, 3, 4, 5 17s. And we know from elementary school, if you have 17 and you have 5 of them being added together, that's the same as 5 times 17. And that gives me an answer. Now, the reason I point that out to you is not because that's anything you're going to need to do in the homework associated with this video. It's because in the next video that I make in preparation for tomorrow's lesson, we're going to talk about shortcuts to this process. And in the case of an arithmetic series, the shortcut deals with the fact that this just happens to all add up to be the same number, and we can take advantage of that. All right, let's finish things out with this particular problem here. Now you can see all the examples that we've done so far have been an arithmetic sequence or an arithmetic series. This one, because it has an exponent, this is geometric. Now that doesn't change the way that the sigma notation works, but it is going to change the pattern that we're going to see with our numbers. And so in some cases, you might feel like that makes the problem a little more difficult. In this particular case, the formula is more difficult and we're working with some bigger numbers. So I'm going to do the same. I'm going to challenge you to pause the video here and try this one on your own first. And once you've got it to a point where either you've got an answer or you've gotten stuck, whichever one comes first, then resume the video and let's see how your work compares to mine. All right, so hopefully you've done this. The first thing you should have done is taken this expression, 2 times 3 to the j minus 1 power, and where the j in that expression is, you should have plugged in the bottom number. So you should have plugged in a 6. So that's going to give me 2 times 3 to the 6 minus 1 power. And that's what you should have done to start with. Then you should plug in the next integer that comes after 6. So instead of 6, the next integer would be a 7. So my expression is exactly the same, but instead of plugging in a 6 for j, I'm going to plug in a 7 for j. And then I'm going to do the exact same thing again, but now instead of plugging in a 7 for j, I'm going to plug in the next integer, which is an 8. And now I notice, oh, this number matches the number that's on the top. That's my cue to tell me that I'm done. So the next thing I'm going to do is take each one of these expressions and simplify them individually. Now, in this case, I'm going to get some pretty big numbers. I don't know off the top of my head. I know what 6 minus 1 is. That's 5. Off the top of my head, I don't know what 3 to the 5th power equals. So I'm going to grab my calculator to help me with these. And you can do this, as we've talked about in the past, using order of operations, where you just take each previous answer and then combine that with the next part of the equation. So if I did order of operations on this first term, I can see I'm going to get 486. So there's my answer to this, 486. But we also know these calculators can handle order of operations. So if I want, I can just type the whole thing in all at once. And that's fine to do as well. So for this term, I'm getting 1,458. And last but not least, maybe the most efficient way to do this is type it in once. And then remember, if you push second enter, it retypes it. Now I can just arrow back and turn the 7 into an 8. And that might be the fastest and easiest way of them all. So this thing simplifies to be 4,374. Now, the sigma is telling me that all of these things that I have found need to be added together. So I'm adding each of these things together. And that's what I'm going to do to finish the problem. So 486, let's screw this up so you can see, there we go, plus 1458 plus 4374 equals 6,318. And that is the final answer to this problem. All right, so there's a few examples going over how to work with sigma notation. One where you're working with a larger group of numbers. The second where you're working with a more complicated formula that generates larger numbers. All right. So that takes care of these videos associated with sigma notation. You've got some homework problems posted associated with these videos that you should try. And of course, coming soon will be another video that takes this and moves it to the next step, which is applying a formula as a shortcut. Thanks for watching. Have a good one.